Hello everybody, my name is Harvey, and today I will demonstrate how to configure LAG, which is Link Aggregation Group, between a Duratec router 2962 and a bigger switch Q2200X. Link aggregation allows you to combine multiple physical links into one logical link to deliver higher bandwidths as well as introducing redundancy. This feature is now available in the figure 2865, 2866, 2927, and 2962. Other routers will be added later. LAN port aggregation is now supported in firmware version 4.4.0 and above for models 2865, 2866, and 2927, and version 4.3.2 for 2962. This demo shows how to set up link aggregation in static mode between a bigger 2962 and a bigger switch Q2200X. This is a brief sketch of our demo today, where we have a 2962 linked by LAG to the switch through ports P3 and P4 on the 2962. And also we have two pairs of PCs communicating with each other simultaneously using the iPerf program while measuring a traffic speed. Note that the PC10 with IP address 192.168.1.10 will be communicating with PC14 and PC13 will communicate with PC15. Now we go to the 2962, check that the firmware is 4.3.2. and we check ports P3 and P4 are not connected yet. Then go to LAN, link aggregation, and then assign each port P3 and P4 to an LAG group. In this case, I've chosen group 1. And then select the LAG mode for group 1. Note here we have a selection of balance-RR, active backup, and balance-XOR. I will choose balance-RR for this demo, and then click OK to accept the setting. According to Duratec documentation, here is a brief description of the three modes of LAG provided by the 2962. The active backup provides only fault tolerance, no load balancing, but both balance-RR and balance-XOR modes support fault tolerance and load balancing. LACP is not supported at this stage. Here is what I got on the internet. Some further description of the different modes of LAG. There are about 6 of them, but Duratec seems to concentrate on the first 3. That is mode 0, which is balance-RR, which has a round-robin policy and provides both load balancing and fault tolerance. Then mode 1, which is active backup, and uses only one link at a time, so has only fault tolerance but no load balancing. And third is mode 2, which is balance-XOR, which transmits based on a selected transmit hash policy and also provides load balancing and fault tolerance. So this is more or less what Duratec has explained in the previous slide. Moreover, contrary to the 2962, the routers 2927, 2865, and 66 support only balance-XOR mode, also called static mode by Duratec. And of course, ports used in LAG cannot be used for port mirroring. Now we need to configure the switch, so we connect one LAN cable from the 2962 to a port on the switch. We can then go to the 2962 and check the switch IP address in ARP cache, which we can see is 192.168.1.11, or alternatively, go to the central management switch tab, status, enable if necessary, and check the status tab to get the IP address of the switch if it has been detected. It may take a minute or two for the info to appear. Same information can be obtained in the profile tab. So we click on the IP address and connect to the bigger Q2200X switch. As usual, we check the firmware version and then go to the Configuration General Setup tab and click Link Aggregation. Then go to the Show Advanced Mode tab and select the two link ports to be used for aggregation. Here we select ports 2 and 4 and click on OK. Oh, we also need to switch the ports enable button and check the port speed to 1000 megabit per second, or select auto. Note that we have our LED state enabled in the mode static. So now I have connected both LAN cables from the 2962 to ports 2 and 4 of the switch. So checking our diagram again and make sure that what we have just done, ports 3 and port 4 from the 2962 are connected using LAG to ports P2 and P4 of the switch. We have also our two pairs of PC ready to run the iPerf test. The PC with IP addresses 192.168.1.14 and 13 will connect to 10 and 15 through the LAG links 1 and 2. We will now run iPerf program between the PCs. Basically, one is set as server with a receiver, while the second one is set as a client and sends packet to the server. The speed is then calculated. Now we will go to PC 10. We'll do an IP config to check that the IP address is 192.168.1.10. We start the iPerf as a client. Hence we type iPerf 3-C to 192.168.1.14, which is the PC 14. We can now see the traffic flowing as I have already set PC 14 as a server. Note the bandwidth speed to be around 800 megabits per second, and that's gone onto one of the two links. I will now go to PC 15 of the second pair and I'll RDP to it and set it as a server, just as I did for PC 14 before. So I type iperf3.exe-s and that's it. Now let's go back to our first PC 10 and relaunch the iPerf program, which we will make it more interesting by adding a few more instructions. Example W2M for 2000 bits packet minus T90S sets the duration to 90 seconds and I1S is to set display every second. Now remember PC 14 is already waiting in server mode. We can see the packets coming at 925 megabits per second, and we will now simultaneously launch PC 15 to receive packets from PC 13. We can now see the packets going on the second line. We have started port 14 first, so we can now see 97% TX in operation. Then we can see port 10 coming up at 96% TX with bandwidth speed of around 937 megabits per second. So we can now have a total bandwidth of 1.8 gigabits per second approximately. I can conclude here that the LAG is working fine. Just before leaving, I'd like to show you the slight differences with routers series 2927 and 2865 and 2866. As per the latest firmware at the time of recording, which is 4.4.2, the LAG mode is restricted to ports P2 and P3 only by default, and the router supports only static mode, that is balanced XOR. The 2962 is a slightly more advanced router. Thanking you for your kind attention. This concludes our demo today.